This is Unit 5 Biology Revision, looking at skeletons and joints. So what does the skeleton provide for us? It provides support for the body so that you are not a heap of muscle and tissue on the floor. It provides protection for the body and a framework for the muscles to attach to. What about other animals? Other animals have got skeletons. Are they similar? Are they different? Let's have a look. This is an example of an organism that has an external skeleton. This is an insect. The external skeleton provides support on the outside of the body, in contrast to humans, mammals that have a skeleton internally. The external skeleton is made up of a molecule called chitin. Now, what makes this really useful to them is that it's very hard, so it gives them some protection. We've got jointed legs here. We've got joints so that it gives them the freedom to move. A downside to this is that it restricts growth, so the animal will have to shed its skin in order to grow and produce a new external skeleton. Some invertebrates don't have any skeleton. Ones that live in water can become quite large because the water buoys them up. Earthworms, for example, have a hydroskeleton, which is fluid inside the body, and the pressure inside the body pushes against the muscular wall and keeps the shape of the earthworm. So animals that have a backbone, or vertebrates, tend to have internal skeletons. Some fish, such as sharks, rays, and things like that, their skeleton are made of cartilage. Although our skeleton is made of bone, there are places where we've still got cartilage, such as the tip of your nose, your earlobe, and the ends of long bones. This is the structure of a long bone. Here you can see we've got an outer covering. The outer layer is bone tissue. This strengthens the bone. Through the middle of the bone, we've got bone marrow. Yellow bone marrow, which stores fat through the middle in adults, and towards the end we've got spongy bone tissue, which contains red bone marrow. It's also worth noting that on the ends, the joints on the surface, we've got cartilage covering this area. Due to the bone marrow through the middle, it's still quite a hollow structure, so that makes it lighter than solid bones. It's also really good at compression, so if we get compression from one end, it's not going to squash down. You're not born with these bones. These develop from being inside the womb up and through infancy and through childhood into adolescence. This is what we'll look at next. The skeleton starts out made of cartilage. Now, this is a substance that's made up of mostly protein, and from about 6 weeks old in the womb, minerals start to be deposited onto the cartilage. These minerals are mainly calcium phosphate. This causes the cartilage to turn into bone. This process of cartilage turning into bone is called ossification. This is a diagram of a bone. Now, when bones grow, cartilage is deposited on each end of the bone. Now, this is where the growth happens, is at the ends. Now, in children, there tends to be more cartilage than in adults at the end of the bones. This is because children are still growing, so we get increasing cartilage, which then becomes ossified, turning into bone. Forensic scientists can use this cartilage at the end of the bones to age a skeleton. We're now going to move on to different types of joints that we have. We've got 3 main types. We've got ball and socket joints, hinge joints, and fixed joints. First of all, out of those 3, we'll look at fixed joints. Now, this is a picture of a skull, and here you can see that we've got plates on the skull. Now, these plates eventually fuse together to become the fixed joints. However, at birth, babies have a cartilage patch at the top of the skull. Now, this allows the bones of the skull that are not yet fused to be squeezed so the baby can pass through the birth canal easier. And once this happens, the skull becomes extremely effective at protecting the brain. Another type of joint that can be found on the skeleton is a hinge joint. Now, similar to a door, we can get open and close. It cannot move in any other direction. This is true of hinge joints. The elbow and the knee are examples of hinge joints where they can move up and down in one plane. With your elbow, it allows you to bend and straighten your arm so you can lift things like heavy weights. The last type of joint that we've got is the ball and socket joint. An example here would be the shoulder joint, but we also have the hip joint. This ball and socket joint will allow limb bones to rotate and give it more movement than such as an elbow, which is a hinge joint. The hinge joints and the ball and socket joints are examples of synovial joints. We've got a picture here illustrating one using the elbow. The elbow being a hinge joint is a synovial joint. We have synovial fluid produced in this joint. This is produced by the synovial membrane, which is found around the joint here. This fluid lubricates the joint and keeps it nice and smooth so that we don't get as much rubbing against the bones, which would cause friction and pain. To also prevent that, we've got the ends of these bones that join together in the joint are slippery and smooth due to cartilage. This also reduces friction and prevents pain when bones are rubbing together. The bones in the joint are kept together by these structures here. These are ligaments. They will stretch and allow for movement so that we can get movement around the joint. Joints are extremely important when it comes to movement. If it wasn't for joints, we wouldn't be able to move. But also, if we didn't have muscles, we wouldn't be able to move either. So they're both extremely important when it comes to movement. When the arm is bent, as seen here, the bicep muscle contracts. The tricep muscle at the back of the arm relaxes. As the bicep contracts, the tendon of the muscle is attached to the radius of the forearm. Now, this tendon is not stretchy, so what it does is it pulls the arm upwards towards the shoulder. On the other hand, when we get your arm straightening, we get the opposite happen. So the bicep relaxes and the tricep contracts. This time the tendon of the tricep pulls the ulna of the forearm and your arm straightens. As we get the bending and straightening of the arm, the muscles in the arm are working together to provide this function. But as one relaxes, the other one contracts. They are working opposite. We say that the muscles are antagonistic, which means they're working together but doing opposite functions.